Hi, I'm very pleased now to introduce Professor Tim Broyd from UCL, who was part of the team who helped to write Digital Built Britain. I'm going to let Tim maybe address Leif's challenge of what a BIM might be.
Thank you, Anne. All right, the magic button. Hold it the right way around, it might be nice to me. Good afternoon, everybody. I feel a lot of what I'm going to be saying has been said or implied already, mainly by Peter Hansford. Thank you for that, Peter. I've got one or two pictures that go with the words. I'm not sure which of these hats I'm wearing. I am a vice president of the Institution of Civils at the moment. Probably not that. I'm a professor at UCL in the weird and wacky area of built environment foresight. I am a director of Building Smart UK Limited, but it's probably a mixture of the last two. I'm going to take you, and my apologies, I couldn't get here before lunch. I've heard one or two things that happened before lunch. If I repeat or contradict, then that's my fault. If I contradict, I might be right, but maybe not. Let's take you back to go forward. Where does this... Right. We started a few years in the UK on this, I think, with the true, hopefully rather than apocryphal letter left on the desk of the incoming Chief Secretary to the Treasury by the guy who was just leaving through the back door. I'm sorry to tell you there's no money left. And the new government had things to do. And that was in 2010, round about May. Within a year, or actually just about a year, on the 31st of May 2011, the government published a new government construction strategy which contained 3 lines on BIM. Government will require fully collaborative 3D BIM with all project and asset information, documentation and data being electronic as a minimum by 2016. That means the end of March 2016, financial years. A staged plan will be published with mandated milestones showing measurable progress at the end of each year. And the very same day, the Minister for the Cabinet Office, Francis Maud, popped up with a press release or a statement noting that... Is there a laser button on this? Is that one, is it? Yeah. Linking that to, which isn't said in the strategy at all, that by doing so, capital costs will be reduced by up to 20%. Now, this is fairly rapid-fire stuff. The government strategy was informed by a report written by industry, though ostensibly coming out under the aegis of the Government Construction Client Group, which contained 6 basic recommendations, and this was commissioned, I guess, the report by Paul Morell, who was the UK's first founding, if you like, chief construction advisor at government and Peter Hansford's immediate predecessor. And with 6, I've summarised the recommendations a little bit here. Leave complexity and competition in the supply chain. If you as the customer take on those, if you try and micromanage, you take on risk. Risk should be left in the market where it knows how to deal with it effectively. Be very specific with supply chain providers. They'll only provide that which is asked for. Give people a contract, they'll answer the contract. Don't expect any more from them. Really. Third one, measure and make use of outputs. Otherwise, whatever you do, other parts of government won't necessarily agree unless you can prove the value of it. Provide appropriate support infrastructure, particularly including help people in procuring government departments to understand what procuring by BIM means. Take progressive steps, don't walk before you can run, and take a clear target for the trailing edge of the industry. I think there might be code, I can say this, Peter couldn't possibly comment, there might be some code there in don't make half of the construction workers redundant in the country. Now, by doing this, government was effectively not trying to legislate, not trying to regulate for the use of BIM, it was just using purchasing power, right? And it affected and affects only central government procurement, which is quite a lot, but is a minority part of construction in the UK. So I think, don't fool yourselves that the UK is taking to this hook, line and sinker. In some areas of it is. In some companies, though, they'll do what government's asking for them on some projects, and they'll do what they've always done on the rest. We're on a time of transition. And then a couple of years ago, we've seen that was published by and through Peter Hansford, and that's the third time this afternoon. I don't know how many times this morning, but it's a set of numbers that is alive and with us. And Peter, I think you gave a much better description and discussion on those than I ever will. What I will flag up, though, is some work that I was asked to do at the same time as the Construction 2025 strategy was being developed, which is to look beyond 2025, right? What's going to happen 2025 to 2050, maybe beyond? And one of the pieces of work I did there was to pull together a number of recent Foresight studies in construction and the built environment. And because I didn't really want to go to all the source material myself, because there wasn't time, certainly weren't the resources, I went to a number of fairly recent publications which themselves had incorporated or taken note of significant numbers of previous Foresight studies. So we have Natural England in the UK in 2011, Urban Development, published by BRE, but this is the results of a big research project led by Chris Rogers at the University of Birmingham, Livable Cities, etc. RICS, the World Economic Forum, and what was then the most recent Foresight study by Shell, who started the foresighting stuff off, I guess, in the 60s. And then because these were all written and presented in very different ways, I then attempted to pull them back into a fairly standard template of thinking using STEEP, really. So societal, technological, economic, environmental, and political. And what we find then is that there's a lot of coverage on economics, on political, on societal. Not bad on environment, but hardly anything on technological. Right? And what's in there are really just a couple of scenarios from the Natural England one. Succeed through science is really their label for what happens if we go to technological farming. So automated hydroculture and whatever. If we really go heavy on GM crops, etc., etc. But the rest of it, and what struck me here was that we're living in a time of quite rapid change, and perhaps what's changing most rapidly is the technologies of the work of the areas we work with, and yet when people are looking ahead, they're ignoring them. I don't think I have an answer to that, but it is a comment. And yet, my pictures, I've got a few fuzzy pictures. It's what you get when you steal things from people's websites, and they're quite small pictures, and they just blow them up. So, So I think this, some of this has come from previous speaker, is aligned with that. For the last 2 or 3 years, you've been able to buy Oakley snow goggles with, let's go back, with heads-up prism displays, which give you an idea of how fast you're going, how high you are. If you're into jumps and turns and whatever, you can replay where your head has been on its way down a hill. If you get lost, as I tend to when I go on the slopes, you can find out, a friend knows where you are, and if you don't move for quite a while, you might be stuck in an avalanche, I guess. But, these are things that are being used, just for fun, really, in sectors. Talking of instrumentation, okay, some people do it because they have to as a living. This is a small part, or the main types of data that are telemetered back second by second, actually fraction of a second by fraction of a second from a Formula One car. This one's going around, there's a name up there, gives a clue, from Monaco, back to race headquarters. And what do we have in the built environment? We have nothing like this. And maybe it's because we never have had anything like this, or maybe it's because with the current economic and commercial paradigms we have, there's no one who would pay for it, even if it gives us some sort of benefit. We have new business models. Rolls-Royce engine, now earns more from tasks such as managing clients' procurement and maintaining aerospace engines, the now cliched, I guess, power by the hour, than it does from making them in the first place. And yes, we've seen the rise, and that comes from just over 2 years ago, and the subsequent fall, temporarily, of Google Glass, and doubtless it'll come back when Google can work out what the markets are for it. And also in the background, we have IT just getting more and more intrinsic to everything we do. So here's a 5-year forecast. It's got 6 years, but it was done in 2012 from Cisco on data over the internet, showing their estimated 30% compound growth per year. And even more worrying, perhaps, or exciting, depending which side you come down, machine-to-machine mobile data, the sort of stuff that now drives and operates and runs increasing amounts of our infrastructure, and both economic and social, compound growth of 90%. And looking further back, the internet itself had its 21st birthday last year, whatever. And let's take that as a time when there were 0 people connected in the world, and we're now at something like 60-70% of people connected within a generation, and we have 20% of them using one application, Facebook. Right? The social sides. No, sorry, I will disagree that BIM is just technology. I think the behavioural, the social, the cultural, the commercial aspects that go along with the technology are extremely complex themselves. And we are starting to use that. So that's David Reboso, the Engineering Director of London Underground, with a comment there that smartphone apps are allowing underground engineers to diagnose tube health niggles before they become a problem, etc. And more in the way. And just in this vein, looking at performance aspects, which is part of level 3, I'll come to that in just a minute, and I won't outstay my welcome. Swiss Railways, some parts of Swiss Railways are now offering a money reduction, fare reduction, for people who will put an app on their phones and just keep their phones on when they go on parts of the network, because this is giving an early warning of potential not damage but track misalignments, right? So that as well as sending a big instrumented bit of rolling stock down the tracks every 3 months, 6 months, whatever, they are now getting journey by journey thousands of little bits of information which are becoming useful to them. So that gets that sort of background. We have the Richards-Bew wedge from 2008 that is sort of standing the test of time-ish. And we have where the government mandate on level 2 is, which is at the edge of file-based collaboration and library management, and before we get things integrated and interoperable. And my contention is that the line was put there for 2 main reasons. Number one, because it was doable. It was doable with what was current technology. And number 2, it was doable without having to change contracts. And in the main, relationships, although relationships had been changed by it. So against that, we had a report launched by government 4 weeks ago today, actually, and it's not 2. Life's running away with you. Or not. Under a new badge, and that's Level 3 Building Information Modelling Strategic Plan, sounds grand, a new badge of Digital Built Britain, co-badged with UCL. And for those of you who haven't come across it, and I have to say, with a bit of sadness, it was very, very softly launched at the end of another event by Vince Cable, who is he still the Secretary of State? it probably ceases to be tomorrow, does he? Or does the Secretary of State go on to the election? He goes to the election, okay. So government's not Parliament's not sitting, but the ministers go on until they don't. So sorry, I haven't put a web address in for Digital Built Britain site into this pack, but you can easily Google it, and it gives the vision for Digital Built Britain. As it says here, Level 3 program will be branded Digital Built Britain. Program will deliver all of the aspirations set out in the 2008 Bew-Richards wedge, but will create relationships, again, not technology by itself, relationships outside the traditional construction sector. Okay. And then to enable interconnected digital design of different elements of built environment, and then linking that to smart cities, right? My personal view is that the DBB Digital Built Britain brand will be used increasingly, partly to move away from thinking about BIM. You know, BIM has baggage, some of it good, quite a lot of it not good. If we want to move construction and the built environment into the information or the digital age, then let's just call it that. Okay. So this report was, as it says kindly there, chaired by Mark Bew, delivered by myself and some of my colleagues with a steering group that included, yes, Paul Morell, but also one or two from UCL and a few people outside. And inevitably, perhaps, we have some talking heads. So here's Patrick McClamey, needn't introduce him at all, of course, but talking about the UK programme is currently the most ambitious and advanced centrally driven programme in the world. I guess there's good and bad on that, depending whether you're having to do it, because you can't, you can't rely on anyone having trod the path before you, etc. We have a guy called John Seeley Brown from Xerox, just noting that most of the world's really smart people just don't belong to the same organisations, and if you really want to make headway, you've got to pick people from wherever they are. Okay? Any new model of innovation must find ways to leverage the disparate knowledge assets of people who see the world quite differently. If you use people who see the world the same, you'll get the same, plus a bit. If you use people who see the world quite differently, in cliche terms, I'd say not those who are trying to think out of the box, but who don't believe there's a box at all, then you might just make good progress. And here's Clay Shirky, New York University. There's a bit of, I can take issue with some of his English grammar here, but I think the sense comes out. Almost every information business that the internet touches, the first thing it does is it rips the guts out of the scarcity model. You're scarce if you're in a location and people have to use you because you're there. You're scarce if you're the only people with certain information that or types of knowledge or ways of doing things that I'm being waved at, it's nice, etc. Once you go into the digital age, a lot of those things go away. Yeah, you still, not that it affects me much, you still can't get your hair cut on the internet, but you can get a lot of other things done. So there is a prototype of a makeup robot. Okay. So the model, this isn't in the DBB Level 3 report. It's a simplified version, which really moves on from Level 2, which I would shorthand as procurement BIM, onto whole life BIM. So moving from capital delivery at the bottom through operational activity and into performance management, and noting that there are different types of aspect and perhaps totally different types of contractual relationships that need to be developed as a result. That one is in the report, and you've seen the sort of thing before, I'm sure, which gives hierarchies of data. So if you're building something, the nuts and bolts information is needed by those who do that sort of thing at the top, and maybe if we're looking at prisons in the UK, they're HM Treasury, the people who provide the money, or our money, through to prisons. They're pretty much only interested in the total cost, right? And the important thing here is you use the same body of data and it provides different cuts on information. So what we're looking at Level 3 is extending that through to operations and performance management in hopefully a logical way, and then noting that different approaches may well be needed in different types of building or infrastructure sector. Yeah. One of the big problems we've got at the moment is we like to talk about performance management. In truth, we really don't know very much about how buildings and infrastructure performs or how we should look to measure their performance. I've got some details in the pack which I won't show. This is the contents list. You can download the report, if you haven't already, directly from the Digital Built Britain website. It's the only report that's linked to it at the moment. But it comes up with a number of actions. You can read the areas probably faster than I can talk, but it is, we've set out to be as comprehensive as we can. And I'll just pick up on just a couple of those in the interests of time. So on delivery, from pragmatic stuff as create a project management office and convene a steering group, and that's being done at the moment, right through to the tougher but really important issues of coordinating with people outside the UK. So we're not just looking at this from a UK perspective, that we can work with colleagues around the world. And so I've got lists in here for each of those. I'll just, because of where I am and the badge, I've got linger just a little bit on research needs. And yes, you can see, rapid capturing, important. We don't do it. Down to security, both physical and increasingly cyber security. Understanding socio-political implications of a smart environment. There's a great richness of needs there that doesn't all have to be met before we can go to level 3, but will very, very much enhance it. I'll just stop. This will be my last slide, Anne. Noting another figure that isn't in the report, but we've used when we've been developing the report. Just noting that there are a number of areas of need, we think, with level 3 that will be pulled together. Hardware solutions, storage, transport, interface technologies, etc. Applications, analysis and use, cyber security, all of those in blue, which we believe the market will provide against. Whereas areas of unified modeling-led languages, classifications, digital plans of work, we really can't see where the business case would be in a fragmented industry for those things to happen other than with public sector financial intervention. In the interests of time, I will leave it there. Thank you.
Thank you very much, Tim. So, John Sullivan, if I can invite you to the platform, please. So, John is from Autodesk, ECO Business Development Manager. You have the stage here.
So, how is my microphone? Can you hear me? Good. Okay. Yeah. Okay. So, I'm John Sullivan with Autodesk. I'm out of Washington, D.C. I'll start out slowly, but I think I'll sort of build some steam. So, Merrick, I want to ask you if you could be my breathing coach if I start to, spin up too fast. So what we'll talk about, and I've got 20 minutes, but I think I can cover this. And also what I would say is that I'm probably dangerously technical, which means not really much at all. And these are pretty technical topics. What I can do is see how technical I am? I didn't even realize I have a monitor I can look at. But what I want to do today is cover Level 2, COBE, and the idea of quality and interoperability. And a little bit about myself. I've been with Autodesk since 1993, which I think is quite an accomplishment. The first half, I worked on the geospatial side of the business, and since 2005, I've been working on BIM prototypes for the General Services Administration, some standards for the Army Corps of Engineers, and some of the projects that I'm working on lately are what we'll show today, which are software utilities to help facilitate some of these data workflow kinds of issues or items, I guess. So, Autodesk and the UK BIM initiative. We've been quite busy, I think, here with several of our Autodesk folks working on these task forces, working on documentation. One thing in particular that I want to mention is the COBie Toolkit. Does this sound familiar for Revit? Have you heard of this? But we have a free toolkit for Revit that allows you to format the information inside of Revit, the parameters, so that you can deliver COBie deliverables. And the other thing to know about it is it will produce both an XLS file or a spreadsheet, but also an IFC. There's an IFC methodology. So you can go both ways with this toolkit. So those are some of the things, but also we're represented on the subgroups of the Management Board, on the Technology Alliance. So we're quite active in this area. And then there's one of the BIM Task Group. You know these components probably much better than I. And Frank Moore tomorrow, another colleague of mine from Autodesk, will be talking about these PAS 1192-2 through 5 tomorrow in another session where he'll go into more detail. So what I want to do is just start a little bit with COBie. We've had a lot of presentations on COBie, but I wanted to do it just a little basic to make sure that you sort of understand maybe some of the schema or how I sort of understand COBie. But in a certain level, it's pretty simple. I think it can become complicated. But it started out about being about buildings. So buildings were a facility divided by floors. The floors were divided into spaces, and the spaces could be, zones could be aggregated spaces could be aggregated to create different types of zones. In the spaces are components, so things in there, MEP objects typically, but whatever may be inside of your structure. Those are aggregated also into systems and then also classified by type. COBie cares a lot about who delivered what when. So the contact aspect of a COBie data set is really pretty important. There's other components to it, coordinates, attributes. Some of the coordinates also could be used for different kinds of things. And for instance, extending it into infrastructure or horizontal kind of construction. If you look at sort of its origination as floors and spaces, and then these move to regions and locations. So there's some capacity to look at horizontal types of a construction for COBie types of deliverables. And I think that's what I want to say about that. There's also level of detail. So two different ways that I'm thinking of level of detail is geometric level of detail and attribute level of detail. And these probably march along and synchronize, but they may not. And I think there's a lot of advantages to sort of thinking of these as two separate buckets of information that you move along and move through your project. Okay, so that's sort of my setup. So what can a software company do in the context of a COBie standard, in the context of the Level 2 BIM, in the context of BIM policy or BIM deliverables? Because at a fundamental level, we're a tool maker. And we produce software tools. Now, these tools are useful more or less depending on how well they're embedded in the context of a process. So one of the things that we've done is this, which is a Revit model checker. And this is a free tool. And this is not going to solve all of your problems. But what we're trying to do, I think, as a software technology vendor, is make things easier to do so that maybe you will do them. And what we're trying to do with this model checker is make it freely available, make it sort of simple, and make the level of quality in the BIM model more transparent to more of the participants that are working on a project. And this one is we're still sort of getting this out to the market. We worked with a consulting firm in Washington, D.C. called CAB Microsystems. So the way to find this now is to Google Revit Model Checker, and these guys will pop up. My plan is to get this up on the Autodesk, on the Revit App Store, and also to Autodesk Labs. But it's made up of three components. There's a plug-in, and it's the shell. And the shell is effectively just the user interface. And it's probably empty when you first open it up. But there's also an authoring tool, which is a separate piece of software, and it also has a user interface. And this is where you can do Boolean operations, greater than, less than, if it's going to be this height, or if it has the right type of parameter. You can build your checks with the authoring tool. And when you do that, you create an XML file. So the model checking tool has three components: a user interface, an XML file, and the authoring tool. So let's go sort of to it. All So here's the interface. It's not really very fancy, but you just basically open this up, and here are some sample templates and some installed templates. So this is what comes with the Revit Model Checker today. And the one that I think is probably the one that we're interested in is this Model Checker for the COBie extension. So not only do we have a Revit extension for COBie or a Revit utility for COBie so that we can format the parameters correctly or that they exist, but we can also check for that. So this is, when you get this is available now, so you can just download the Model Checker and you'll get the COBie checker with it. There's also something that's, I think, really just interesting about model checking in general, which is if we can interrogate the model down to the object level and every attribute that's in every object in the BIM model, we can sort of tell things about the behavior of the BIM model without really having any templates at all. If I have a large building, I don't know, 100,000 square feet, and I do a query or I do a check and it tells me there's 4 doors in this building, I know I probably have bad modeling practices in my BIM model. So I think there's also value that you can get from this model checking tool without using any of the templates whatsoever. But we have a couple. I mentioned I did some work on the Army Corps of Engineers. They have something called M3, the Minimum Modeling Matrix, that has a lot of LOD detail. We have a check for that. But also Singapore, Starbucks has one. And the way that these are effectively built is not really very high-tech. There'll be someone who is sort of well-versed reading standards or delivery specifications in your organization, and they'll read those specifications and translate the logic of that specification through the authoring tool into these checks. So here's what happens. It's really pretty simple. You open up Revit, you open up the BIM file, and you run the check. And this is an XML file, maybe HTML. But it will tell you what passes, it'll tell you what fails. And it will say exactly what failed and why it failed. And here's one created by. COBie really likes this parameter that it needs to know when it's created by or who. And if you want to go to it, you can hit the show button and it will zoom you right to that part of the BIM model so you can look at this object or fix this object or rectify the issue. But one of the powers, I think, of this is that this is a simple XML file. It's an HTML file. There's a lot of ways you could distribute it, like attaching it to the email and sending it to your contractor, or attaching it and sending it to your design lead. So the idea here is that owners of projects probably don't have enough expertise in Revit to interrogate a BIM model to understand what kind of deliverables they're getting. And it's quite a challenge. But with this, open up Revit, open up the file, run the check, you can read it. So it makes it really simple and really transparent to understand the quality of the information based on a standard that you're trying to deliver to. Here is the interface for the COBie check. So here we're looking at the type parameter, and under type are all these different types of checks. Now this one's sort of a simple check because I think this one might be checking just for the existence of a parameter. And I said this is a tool. This is not a solution. This is not going to do everything. And I would highly recommend using this in combination with a tool like Celebrity because they can do much more sophisticated types of checks. But to get a lot of the basic stuff done that's sort of just mundane and takes a lot of energy and a lot of effort, this is a great way to do it. Here's another one. This is the Army Corps of Engineers. If you want to go and look at the Army Corps of Engineers minimum modeling matrix, you'll see a table of contents that looks pretty much the same as this. So when you build these configuration files, it allows you to structure the table of contents for your checks to match the table of contents in your delivery specifications. So when you look at this and you look at the specifications, the whole project team is going to sort of understand where you are in this part of the check. You can run one check. You can run all the checks at the same time. You could build checks just for plumbing, just for structural. You could build checks for the third floor. You could build checks however you want to do it. Here you can see, I like this one because it showed a different kind of check, maybe a little more fancy check, but I can look for minimum height of a partition wall. So there's a lot of different kinds. It's not just, it does check for existence of parameters, but it does other things too. Here what we did is these are required items and these are optional. So there's a little bit of, customization you can do depending on what your delivery specification is demanding. Okay, it was working. Oh, so the next logical extension for this could be if someone, maybe we could do it, takes the authoring tool and takes what we already have with the COBie. We can do the COBie checks right now, but we could parse them or divide them up into data drops. So if we have an understanding of where the first data drop is, the second data drop is, the third data drop is, we could build checks that would be specifically for those drops. And it would be really simple for the whole project team to say, do you have all the information for each step of these drops, for each stage of the project? How am I doing, Merrick? Okay. Okay. And what I want to also do is sort of be clear as to this isn't really magic and it's not really high tech. But what will it do? It checks for the existence of parameters, a parameter blank. Does it have the right format? Does it have a specific value? Or if you have a pick list, is it a member of the pick list? So these are some of the things that it does in a really pretty straightforward and simple fashion. On the geometric side or the geometry, it looks for things, if they exist, if there's duplicate elements. But these are some of the things that it doesn't do. So spatial relationships between elements is still probably beyond the grasp of this checking tool. So it will do some of your work, but it's not going to do all of your work. And also embedded elements. So if there's things that are built inside of each other, it looks like that is not something that we do just quite yet. Okay, so that's that. I don't know if there's any summary comments that I want to make, but this is a free checker. You can Google it, you could download it, and you can exercise it. And then please, john.sullivan@autodesk.com, please tell me what a piece of junk this software is. Because that's how we can get it better. And I've got CAD Microsystems on contract, and they don't get paid by the code, but by the scope. So I would like to keep them busy improving this. Okay, switching over to IFC. I'm going to say a little bit about this, but one of the things is since 2012, I think, we've released an open source export toolkit for IFC. So one of the challenges with getting IFC better, iterate it more, was that it was locked in place with the releases of Revit. And at least historically, we would come out with a release once a year. And what we wanted to do, one of the things that we wanted to do is able to accelerate that if possible. Also get community involvement. Also sort of push it out because IFC is, an open standard, a community standard. Let's, go with that concept and let's make IFC an open source library. So it's been an open source library, I think 2012, maybe 2011. But what we're doing now is we're working on the speed issues is one of the things we're working on now. And I mentioned previously also that we have a user interface for the COBE. So that's here. And we've been keeping quite busy, keeping the open source sort of up to date and improving. Here's the downloads that we've got. So since, this is a little bit old, August this summer, but we have 60,000 downloads of the open source toolkit. So it's getting well exercised. If you would like to get a copy of the open source toolkit, it's in two different places. Here on sourceforge.net and also on the Revit App Store. 2x3, 2x3. Also, I guess I should say, there's IFC capabilities in the current Revit version for IFC 4. And so what we're doing now is working with Building Smart and Building Smart International on the testing processes and the testing methodology so we can have a certified IFC 4. But from sort of our point of view and our programmer's point of view, that functionality, we don't know until we run against the certification test, but it's in there. Oh, I got ahead of myself. The other thing that I wanted to say is that, we really like IFC for several reasons, but one of them is one that David Jellings mentioned this morning, which is if we can write into IFC or if we can read out of IFC, that's just one file type that we need to do. And it makes our life simpler on a certain level. But also, these are some of the other types of file formats. So here's COBE, here's the 2x3 version of IFC, here's the version 4, IFC 4. But here's my legend up here. Here's the export going, export, import, and import, or if it takes 2 steps. So I wanted to show this because we spend a lot of effort, I think, with our different products, and we probably would like to spend less effort for different types of file formats. So here's City GML, Land XML, the Energy GBXML, and then some of these IFC formats. But the list actually goes on. FBX is for renderings. And you can see DWF, DWG, DGN. and also relational databases. So, the notion of geometry and attributes, and it's not really a clearly defined notion, I think, with AEC software, but with geospatial software, it's a much more mature concept, that the geometry is in one database and the attribute information is another, and they sort of talk to each other in a synchronized fashion. And we do some of that, but I'm not saying it's a fabulously elegant methodology. Point clouds also. So AutoCAD Architectural, Civil 3D, all of these softwares. And then this is a fabrication file format, I believe, digital elevation models. But there's a lot of different file formats that we work with sort of on an ongoing basis. And each one of these, I think it was built or sort of emerged because of a business process issue that it was trying to solve. If we can create more model view definitions, more IDMs, leverage IFCs, to more business use cases, I think that would be great for everyone, and it will be great for us also because there may be potentially less of these different file formats that we have to keep up with. Oh, I think I'm done. So this is what I wanted to say is that I'm using this slide because I'm so terrible at PowerPoint that if I can steal someone's wonderful graphics, I'm going to use it, even if I'm not quite sure what I'll say about it. But these are the file formats that are read by Glue or BIM 360, another just batch of file formats. And with that, what I want to do is just sort of recommend that my colleague Frank Moore will be speaking tomorrow in more detail about some of the technical aspects of COBE. And with that, I think I'm done.
John, thank you very much, and thank you very much for the last three speakers, actually, because you've allowed us to get back on track. Okay, so it gives me great pleasure to invite Leif Granholm back on stage again now to talk about the future of big data, Internet of Things, virtual reality, augmented reality, mixed reality.
Okay, yeah, thanks. Good afternoon again. Yeah, I took the liberty of extending the topic a bit. It was originally just big data, but Internet of Things is very much related to this, so I'm going to talk about that some too, and virtual reality and augmented reality as well. So I like this what is stuff, so we will start with what is big data. That's not so clear, especially in Europe. In the BIM circles, big data has not been that big a topic yet. It has so in US, and in US they have this very interesting definition which I found. Big data is when the amount of data becomes part of the problem. This is a very pragmatic view of big data, and I really like this when I found it, but I also have a bit more scientific definition of big data. And for me, there are two kind of big points with big data. One first is that it's voluminous. We have lots of data and large amounts of data, but probably even more important is this business with structured, semi-structured, and unstructured data. I was talking and advocating and promoting structured data very much in my previous presentation, but we are stuck with a huge amount of unstructured data. And that semi-structured, unstructured means that it's whatever kind of data. It's images, audio, video, human-readable text, whatever. And the point here is that that data has the potential to be mined for information. So we can process, analyze, use that information in different ways, combine it. That's the point of combining different types of data. So in big data, we have three V's. And this is a very, very good picture I found, which kind of depicts the problem very well. So we are expanding on three fronts and rapidly. So we have data velocity. What is the intervals? What is the kind of frequency we receive new data? And we start from simple, from batches. We get data batches from sometimes. And these kind of BIM exchanges are in this category. So then we have periodic, that we have a fixed time period during which we get new information, new version of the same or totally new data. Then we have some kind of near real-time data, and then we have total, absolute real-time data, which comes at the instant when something happens, we get the data and receive that and process. So that's kind of one dimension in these three V's, not 3D. The other one is the data volume. So that's increasing. We are talking about megabyte, gigabyte, terabyte, petabyte. So we have huge amounts of data, and it collects up quickly. And the speed is kind of increasing, so it's almost an exponential development on the amount of data we receive. And then the third one is this variety, that we have data. We have different kinds of data that we need to deal with. We have simple tables, lists, that we have simple Excel sheet. Then we have databases, which are structured, photo, web, audio, and then we have social media, video, unstructured, whatever mobile data that we can collect, routes, positions. It's kind of unlimited numbers of different data that we can receive and process. So this is a kind of indication of a new style of IT which is emerging. So we have started from mainframe, punch cards. I'm of the age that I have actually started my career in IT with punch cards, that we had a box of punch cards and took that to the reader, and next day we got the results back. So then came client server, PCs, then came the internet, and now we are moving to this total mobile, social, big data, the cloud, and also clearly we are moving away from the PC as or even phone and tablet. Those are kind of intermediate. We are moving so that we interact with all kinds of IT all the time. We have wearables, we have sensors in different things. One good indication is that I have this watch. I can read my email from here, and this is just a user interface to the phone. And same car in development is going, that car IT is that it's just a user interface to the phone. So as an intermediate, the phone is becoming, mobile phone is becoming kind of a central device. And the processing power we have in our phones now is roughly the same than we had in a PC, say 4 or 5 years ago. So these miniaturized devices are catching up really quickly. And that's because the upper end has stalled, because we haven't had any faster processes for the last 5 years. They have stalled. The speed of a single processor has remained more or less the same for the last 5 years. And with all of these devices we produce, and softwares and environments, we produce a huge amount of data. One number I found was that in 1 year now we produce more data than in all times before that. So it's an exponential, very sharp exponential increase in the data production speed. Then this Internet of Things, as I already touched, this touches this very much. And this Internet of Things is quite interesting in the point that this is actually a standards leveraging exercise. The point with Internet of Things is that we take uniquely identifiable embedded computing devices and connect them with the existing Internet infrastructure. So this is, and Internet is all about standards. And web is all about standards. So what this exercise means is that we leverage these existing standards. Until now, this kind of automation, sensors, connecting has been very proprietary protocols, proprietary connections, proprietary hardware, which means this has been expensive. It has been very expensive to build automation. With this, you going over to the Internet of Things, we can slash about 3 zeros from the prices. That's one aspect of going for the standard solution. The other one is that at the moment in the world, in total, we have maybe something like 100,000, 200,000 people who are capable of developing, programming, building these kind of any kind of automation and sensing systems. When we go over and move to the standard Internet protocols, suddenly we have tens of millions of people capable. So this means a total explosion in the kind of competence and knowledge and capability to develop these systems. And that means that it becomes feasible to use automation in so many new places. And we have heard about smart buildings, smart cities, all of these things. And this will be a total explosion today. Today you can buy a computer, Raspberry Pi, UK-made product, which is a complete computer. It's the size smaller than a cigarette pack. and it costs you 40 euros. And it's a powerful computer. It can do the same, it has the same guts as the phones have, so it has a 2 times 1 gigabyte processor, 1 gigabyte of memory, and it's a complete computer with graphics drivers, everything, audio in, audio out, and with that you can do things that you couldn't even dream of before doing automation. And it's easy to maintain. It runs on USB power. It doesn't need much power. So this is the kind of first indications of this. And it's getting smaller and smaller. There's the Arduino kits with our even smaller and smaller battery pack. You can get a processor which will run 1 month with a battery. So you don't even need power, wireless communication, everything. So that's not a full-blown computer, but you can do lots of things with that. But this uniquely identifiable is also very important, that you can access it. You just plug it into the internet and you can access the device like that. And the best example of this is these internet cams, webcams. You can buy a complete camera with zoom, banner rating and all for about $50, which you just plug onto wireless network or the wired internet, and simply through a web interface you set it up and it works. It's totally trivial. Cisco has got this. We come back to the robotics. Also, controlling robotics, making all kinds of automation becomes so much more cheaper. So your highly mobile workforce, customers, and supply chain demand anytime, anywhere business tools. And Cisco's position is that an IoT platform can help here. And as I said, it's all about standards. So based on international base standards, we have the link layer, physical standards, how we electrically connect devices, internet layer, transport layer. We have more transport layer, application layer, data formats, which can be used in. So the Internet of Things is all about standards, totally about standards. And of course, the miniaturization of electronics in general that we are capable of making, low power, high performance electronics. But the more important point is the standards. One interesting thing then about big data, I did this Google Trends, where you see that the trend is quite rising at 2013, and this is not just for BIM, this is for any kind of interest for big data. It's growing quite quickly, but even more interesting from the European point of view is the 10 most interested countries. India, Singapore, South Korea, Hong Kong, Taiwan, US is down there, and in top 10, 0 European countries of interest in big data. So this is something for Europe to think about, and there needs to happen. It seems that India, but like Sri Lanka, is quite surprising that Sri Lanka is on the top 10 of countries interested in big data. Then if we look a bit on the characteristics of big data, so as was the first one, when it becomes too much data to handle with traditional tools, local servers, databases, desktop software, new approaches are needed. And this is also very important that there's less reliance on formal schemas and data quality, more focus on raw data, extended metadata, pattern recognizing algorithms for analyzing, processing, mining the data. But this does not mean that the interest for schemas and structural data would go away. We just, the kind of importance of that raises also with big data, but this other data will probably become more important, or at least as important. But this also builds up the interest and importance of the structural data, because we need the structured data to keep the whole thing together. And we need to harvest, store, and analyze that. And to do that, we need definitely new tools. That can be done with the traditional client-server environments or desktop computing. We need cloud computing. We need highly distributed parallel processing, no SQL databases. SQL databases can't handle this kind of volumes of data and processing. And we need a semantic web and linked data also for this. To do one of the most, in the previous slide I had this Hadoop MapReduce, and these are totally central tools for the big data problems. How do you scale the applications? Lots of cheap computers, so this is the highly parallelized computing, 15 minutes on 1,000 computers, reliability problems and common infrastructure. And the solution to that is an open source project called Hadoop. The interesting thing is that Doug Cuttings, he's the kind of father and creator of Hadoop, and that name is his son's stuffed elephant. So interesting how these things get named. Names are important, and it's very important. It has two main parts, Hadoop. It's a distributed file system which just distributes the data on several storages fairly transparently, and MapReduce, which then distributes the kind of tasks that you want to do with the data, and those work in conjunction together, so they kind of schedule the task and know where the data is and where it goes. It's written in Java, it runs on all major platforms today, and it runs on commodity hardware. And one interesting development is that these kind of very dense server clusters are built with ARM processors, which are RISC processors, which are the same processors used in mobile phones, which are very low power. So you can pack a lot of those in a small space to get lots of processing power. And there are huge Hadoop clusters. Yahoo is, by the way, a bit strange thing that it was originally created at Yahoo, but it has been taken over by Apache since, and Yahoo uses a cluster of 20,000 machines running Hadoop. Biggest single clusters are 2,000 nodes, several petabytes of data, and hundreds of thousands of jobs every month. And the interesting point is that who is using it? So you see all the big names in the social media and in the kind of social networking and public networking, all like Google bases, its total processing power is based on Hadoop. So this is something you will definitely hear more about as the amount of data keeps building up. So then if we look a bit of BIM, what it means for BIM. So we have two sides here to consider. One is the sources of data, where we get the data from. And clearly we get this semantic data that will kind of be the skeleton of this big data that will hold it together, that will give you navigation, how to navigate it, how to find around in the data. Then we'll have different kinds of sensor data, LiDAR data, images, videos, logistics. That this will be a big source of material in the future when we start to use more real-time tracking of everything that moves around, all the deliveries, even down to single materials when we get these miniaturized computers that we can not just RFIDs, we can fix an intelligent computer on every piece of material, every collie we are following. So this will be a big source of information. Augmented reality devices and apps, those are also producing, because when you use the augmented reality, you can store that augmentation as a video and use that later on for many purposes. On-off-site fabrication machinery, of course, from the machinery you will get a lot of information about the material, like these machines which I showed, the robot, which I showed in my earlier presentation, where you make a kind of theoretical model of the steel you are going to cut with that machine, and it has a LiDAR built in, so when you put a new beam in it, the first thing it does, it scans the beam, so it can adjust the program to cut the steel to the actual steel compared to the theoretical steel. So you will also be able to record the raw materials that you used in the data. And the amounts of data you will get from this kind of information is huge because it's point scans mostly. Process data, schedules, workflows, quantities, product data from manufacturers, that as we get more and more, that will eventually get into the big data category, all kinds of process data, and then geospatial data, of course, cadastral, building regulations, terrain models, scans, existing structures. Traffic information is, if we kind of extend a bit to just from buildings and roads to smart cities and infrastructure, that will be a huge source of all kinds of information. And for instance, Google is already using that. They are collecting information from the phones, from the people about traffic situation and using that in real time for navigation. Then what can you use this for? Of course, virtual reality is a big application because we can use analysis, processing, and visualize all kinds of information, combine information from several sources, and visualize that to the user both construction time and facility management time. Like Trimble has a prototype which we have shown publicly, that you roll around with the tablet and you point it somewhere, you see X-ray vision of the wall, what's inside behind the wall, of part of which can be scanned information, as-built information, part is designed information. You can combine those. Then automatic information deliveries, of course, quality control you can do when using the kind of huge processing capability that you get with these low-cost computer clusters. You can do automatic checks much more extensively and specifically use images, scans, together with the semantic data to do the controls that is what you built actually up to what you planned. Automated schedule, quality, and budget follow-up. When you collect this big data, you collect the logistic information, fabrication information, all of this, you can automate much more your schedule, quantity, quality, and budget follow-up, which today is to a large extent a totally manual operation. Automated design as well, you have more information, you have all designs which you can access much better than before, which you can use. Automated fabrication, building inspection, we have talked about that. That's when you can collect data, when you are doing your inspections, you can collect data on site kind of very indiscriminately and then process it afterwards. You don't need to be so careful that do I have enough price, do I have enough capability to process this. You can indiscriminately take images, videos, scans, whatever, and then you process them afterwards. And of course, facility management is a huge application for this. So that was all. Okay, thank you.
Okay, thank you. That was perfect timing. So are there any questions for Leif there? There must be some questions.
Well, last presentation, so people start to be a bit tired. Yeah.
Okay.
Again. Thank you.
Okay, so thank you everyone for your attention today and your patience with some of the hiccups, but I hope you've found it an insightful day today. It's been quite a visionary day looking at the strategy. I think tomorrow we'll be going into some of the depth and the how-to, which I think will be really fascinating with quite a few workshops for you to select and go to. But I really wanted to just quickly summarise for you today where I think we've really gone on this journey. I think there's been two parallel journeys really that we've heard about today. One, which is that of building smart, where it came from, how it was first set up and how it's developed and how it's maturing. And it's fantastic to have been able to hear a number of the chapters telling us what's happening around the globe. The second has been our BIM journey, and particularly focused today on where we're sat in the UK. So in a way I feel apologetic to that because it's very clear that BIM is occurring across the globe and it is becoming quite a phenomenon. I think, in the UK, what we're really talking about, it is a UK BIM programme. And this is how to implement new technologies to introduce greater efficiencies to our industry. And it's really giving a firm foundation to how we establish digital built Britain. So it is this thing about this is not an indecent, undignified race to level 3. We need to get the cornerstones in place before we dash off. And this is where I think we've determined that there's such an important link between the BIM journey, whether it is within the UK or how it's kicking things off in the Middle East, as I've certainly been discovering over the past couple of months, and in India, or in partnership with Europe and with the United States. So, I'm really fascinated about the fact that actually Digital Built Britain is utterly dependent on developing international open standards, and that emphasis being on international. So what a great opportunity for Building Smart to be part of that journey and to be influential, which is where I think it's so important that we start from that concept that Patrick really introduced today of IFC, the International Friendship Club, where it is perfectly acceptable for us to collaborate. It's perfectly acceptable for Leif to challenge me and tell me that he thinks I'm wrong about what BIM is, because that's what collaboration's about. We should have a relationship which is big enough to challenge each other, have a good fisticuffs, and then I hope he's going to go and buy me a nice drink later on. But that's what this is about. We have to be able to have challenges, to argue, and then come to a consensus, which I think is what is the skill and the talent of Building Smart and OGC. So we've got a number of people who work in both organisations and who seem to have such a talent for being able to pull this off. So I think this is a great celebration today of what these two journeys are and how interdependent they are, because actually there's something which we have in common. And that problem statement, I think, is how to stop data becoming a part of the problem, just as Leif described just now. Whether it's open and structured data, or whether it's this chaotic, unstructured data which is generated by numerous devices, including ourselves. So my final point is that maybe we should be thinking about what the unintended consequences could be. So Google Glasses, 24th of October, there was the first incident of internet addiction disorder from Google Glasses. Someone was taken into a clinic because he'd been wearing Google Glasses for 18 hours a day and couldn't quite get off them. So when he went into the clinic, they took them off, and a couple of days later, he was still trying to control and flick. And I know that because I'm a bit like that with my iPad and my iPhone. So my point really here is that, we talked a lot about data, how to make, work with intelligent computers, automated devices, with robotics, intelligent infrastructure. How do we ensure that actually we keep ourselves as being intelligent humans who aren't merely consuming the data, but we can actually digest and make sense of it? So we're able to engage, we're able to reflect, and we're able to make humane and socially responsible decisions. That, to me, I think, is one of the biggest challenges we should try to meet as an industry. We can do great, clever stuff around data, thinking about the process, how to be able to visualize that. But how do we ensure that actually we're able to get humans to engage as individuals and then collaborate and make those better decisions? So that's really, I hope, a helpful summary for you for today. I'd like to thank all of the speakers today for meeting the challenges, for helping to keep to time. I really appreciate that. Thank you very much to the organisers, to BRE for putting the event together. And finally, to yourselves, the audience, you've been really patient. It's been a particularly long afternoon. Thank you very much for sticking with it, and have a safe journey home. Thank you very much.